Hi. So we can actually go to our new packets. We'll be starting on the first page talking about the types of different angles that we have. You probably have learned these before, but we are going to review all of them, so don't worry. So what I'd like you to do is pause the video and try to fill out this top box and see if you can remember the names of these type of triangles, and then resume and we'll go over them. Alright, so if we have a triangle with 3 acute angles, acute meaning less than 90 degrees, then we just call the triangle acute. If any of the angles are obtuse or greater than 90 degrees, like for example, this one here is greater than 90, you call that an obtuse triangle. If any are having a little box indicating 90 degrees, that's a right triangle because it has a right angle. And if all the angles are equal, they have the same markings, we call this equiangular. So it's like equilateral, but equiangular. So again, I'd like you to pause the video, try to fill in numbers 1 through 5 below, and then we'll go over them together. Okay, so we have triangle CDE is the first one. So if you look here, that definitely has a right angle, so we're going to call this a right triangle. We'll put our reasons because that will help us when we go to do proofs, and we'll say angle E is 90. Next one is triangle BCE. So you're looking at the size of the angles. B and E are acute, but C is obtuse. So this would be an obtuse triangle. You can say angle C is the obtuse one. Then we have ABE, which hopefully we notice they have all the same markings in the angles. So that is called equiangular. Then BDE is this big one, BDE. So B is small, D is small, but E is definitely bigger than 90. So this would be an obtuse angle because of angle E. And then we have CFE, which is this one over here. So be careful, that box over here, this box is actually bigger. It kind of goes outside of this blue triangle, so it's not right. In that case, all of the angles are less than 90, so that would be an acute triangle. As always, if you have any questions, please just send me an email so that way we can work something out. Now we can also classify triangles by sides. So again, try to fill in those boxes and then we'll go over them. Oops, just want to move this. Okay, so if we have 3 congruent sides, we call that equilateral. 2 congruent sides is isosceles. And if they're all different, it's called scalene. And again, I would never judge you based on your spelling of these as long as you have the right idea. So again, try 6, 7, 8. We'll go over those. Alright, so we have JKM is the big whole triangle, right? So this whole triangle. So we have a 1 tick mark, we have a double and an unknown, and then a single tick and an unknown. So they're all different. That's why it's scalene. KLN is this little one over here, and these have the same tick marks on them. So that means 2 are the same, 1 is different, isosceles. And then the last one is JKN, which is over here, and they all have the same single tick marks. So that would be equilateral. So now we're going to classify by the angles and sides. You're always going to classify by the angles first. So the first one is definitely a right triangle because we have this 90 here. And we have 2 sides the same, so we call it isosceles. The next one, we have a bigger than 90, so that's obtuse. We don't know anything about the sides here, so this one we have to say scalene. Yes, it is true that these 2 sides look like they're the same, but we can't assume they're the same unless they actually have, like if they had tick marks on them, it would be isosceles, but they don't, so we cannot make any assumptions there. The last one, all the angles are the same, all the sides are the same, so this is equiangular, equilateral. Alright, so please pause the video again, try 12, 13, and 14, and then you can check. Alright, so number 12 is acute because all the angles are smaller than 90, scalene because all the sides are different. 13 is right because we have a right angle, scalene because we don't know anything about these side lengths and they don't even look the same. And the last one, this is obtuse because of the bigger than 90, and isosceles because 5 and 5, two congruent sides. Alright, the next one we have to use a little bit more information. So we have to make sure we read the directions because they tell us a lot. So first of all, PR bisects angle SRT, meaning it cuts it in half. So let's go find PR, and that is bisecting SRT. So that means that those two are going to be the same. So if the top is 30, the bottom is also 30. Next section is that U is the midpoint of segment RT. So U is going to be cutting RT in half. So if one side is 8, the other side is also 8 meters. Now we should be able to figure out everything. So we want triangle UQR, which is this one here. So that has an obtuse angle, the 120. And the sides, two of them have the same markings. And oh, we should also mark that, right? So if that one's 8, this one also has to be 8 meters. So that would be isosceles because we have 2 8s. Triangle RST is this one over here. So RST looks like all the angles are 60, right? Because here when you add 30 and 30, it's 60. So that would be equiangular. Whenever it's equiangular, it will also be equilateral because it kind of goes both ways. If all the sides are the same, all the angles will be the same. Same thing if all the angles are the same, which makes sense because here we have 8 and 8, which is 16. Here we have 8 and 8, which is 16. And here we have actually 16, right? All right, we have SRQ next, which is this right triangle here. Very clearly it's right. And it looks like all the sides there are different. So we would say right, scalene. Then we have triangle PRT, which is this one here. So we have a 16, a 16. So we know it's isosceles. And this angle down here is definitely bigger than 90. So that would be obtuse, isosceles. Next is TQU, which is this little guy here. And all the sides are 8. So if all the sides are 8, that's automatically telling us it's both the equi ones. So equiangular and equilateral. And then the last one is PQT. We have an 8, a 16, an unknown, so it's definitely scalene. And we actually don't know, oh wait, we do know a little bit about the angles because we have vertical angles here in the middle, right? So if that side is 90, this side is also 90 because those are vertical. So this would be a right scalene. Alright, next section is going to be classifying triangles using the coordinates and the distance formula that we did the other day. So what we'll have to do is find all the 3 side lengths and then compare them to see if they are all the same, 2 the same, or none the same. So what we're going to do first is take just J and K. So I'm only looking at these 2 points for the distance formula here. So we're going to do square root of, remember we're subtracting the x's. That would be -9 minus -7 squared plus, and then subtract the y's, so that would be 1 minus negative 7 squared. I'll show you, actually don't have to go all the way on these. You'll see what I mean. So let's keep simplifying. That becomes square root of negative 2 squared plus 8 squared. And negative 2 squared is 4. 8 squared is 64. So we're running into our space here. That's fine. So it's square root of 68. You don't have to figure it out as a decimal. All right. Then we'll do KL for the next side. So these just take a while. That's why I'll never make you do too many of them. So KL, square root of, do the x's first. So negative 1 minus negative 9 squared plus, and then the y's, negative 1 minus 1 squared. Be careful, negative 1 plus 9 is positive 8. And then negative 1 minus 1 is not 0, it's negative 2 squared. Now hopefully you can see at this point that these two are exactly the same, right? So this is also going to be square root of 68 because this is 64, that's 4. So far we have two the same. So far isosceles, but we also have to check the last one, which is J and L. So now we're looking at the purples. And again, we're subtracting the x's first. So it's negative 1 minus negative 7. These actually both work out to be the same thing. So they're both going to be the square root of 6 squared plus 6 squared. We get 36 and 36. Hopefully you know that's not 68. If so, you can stop there. Just say isosceles because you know that one will be different. If not, you can just keep going, and then you're just comparing all these numbers. So two the same, one different, isosceles. So we're going to skip 22 just for the sake of time. I would like you to pause, try 23, and then check your answer. All right, so 23 should have also been isosceles because these two are the same. Okay, next we'll be solving for sides with algebra. So we have triangle ABC. They tell us that it is equilateral, meaning all sides are the same. So that means that all of these will be equal. And if you have to solve for two variables, what you're going to do is solve for x first and then solve for y. So we're going to take our first one, 3x plus 1. We know they all should be 49, right? If one is 49, they should all be 49. So then you're just equaling it to 49, solving with regular algebra. So x is 16. And then similarly for y equals 49. And that would be 80 and 10, which is 90. So then y is 5. Okay, next one is also equilateral. But now all we have to do is find x, no y, and the measure of each side. So all of these should be the same. When you have three expressions, you can't set them all equal to each other. What you're going to do is just choose any two and set them equal because it's equilateral. So I'm going to do these two. But you can pick any two. You'll see you'll get the same answer. So we'll have 12x minus 22 equals 10x minus 6. Here you go with your regular algebra. Subtract the 10x, add the 22 to negative 6. So that would be 16. And then x is 8. And then you're just plugging it back in to figure out the sides. So this would be 10 times 8 minus 6. 80 minus 6 is 74. So each side should be 74. But what you might want to do is just plug it in everywhere. So do it here too. 7 times 8 plus 18. Make sure you get 74. Yeah, that would be 56 and 18, which is 74. And then this one is 12 times 8, which is 96 minus 22, which is also 74. But that's the final answer, final answer. Okay, I think we should have enough time that you can try numbers 3 and 4, and then I'll move the box and you can check your answers. All right, so we have all sides are 27 in number 3, and number 4 we have isosceles, so that's why we had to set these two angles equal, or sides equal to each other. So if you didn't get that one, don't worry. We're going to do another example like that together. So we say that number 5, we again have isosceles triangle. They tell you which sides are equal, so you can go mark it on your diagram, because sometimes it's not the ones that look equal. So now we know that's where our equation is coming from. 6x minus 77 equals 3x plus 4. Subtract 3x, add the 77. So x equals, I think it's, I want to say 27, but let me just double check. Yeah, 27. And then you're just plugging it in everywhere. So wx is 6 times 27 minus 77. You could use a calculator. It is 85. xy should also be 85, but just check with your calculator. And it is 85. And then wy is 5 times 27 minus 31. You can use your calculator. You should get 104. Okay, again, if you have any questions, please send me an email so we can make sure to discuss it the next time, or through email, or we can meet. Okay, now the next page we have problems where we actually don't have any pictures, but we can still definitely solve these. We're actually going to do number 8 first. So they tell us that triangle MKL is isosceles with MK congruent to ML. You do not have to draw the picture. This is telling you that MK equals ML. So that is your equation. MK equals ML. Do not just take these first two and set them equal. That's like the most common mistake that I see. All it takes is like one little second of just reading that and bringing it down here to know which ones are equal. Because if you just always take the first two, you're only going to get it right probably 33% of the time. All right, so we can go set our equation now. 7x minus 15. There we go. 7x minus 15 equals 10x minus 42. So I'd subtract the 10x, add the 15. So negative 42 plus 15 is, I want to say again, negative 27. But let me just check. Yes, it is negative 27. Divide by negative 3, so x is 9. And then again, you're just plugging it in to find all the other ones. So 7 times 9 minus 15 is 63 minus 15, so that's 48. ML should also be 48. So if it's not, it means, go back and check your work. So that's 90 minus 42, it's 48. So we're good. The last one should be different, or else it would be equilateral. So this is 4 times 9, 36 minus 5 is 31. And then the only difference for number 7 is, first of all, it's equilateral instead of isosceles. And second of all, we have to write these out again. So this will keep coming up. I know we did it earlier in the year too. So 1 less than twice x. Remember, whenever it's less than, you are switching their order. So ST is 2x minus 1. SU is 37 less than 5x. So again, we are switching the order because it's less than. So 5x minus 37. And then TU should be pretty easy, 11 more than x. So x plus 11 for more than. Now, since it's equilateral, we can pick any two. So I would pick the ones that have the smaller numbers, like ST and TU. It doesn't make a difference. You'll get the same answer no matter which one. So I would subtract x on both sides, add 1 to both sides. Nice and easy, x is 12. And then you're just going to go and plug it back in to each side. So 2 times 12 minus 1 is 23. SU is 5 times 12, which is 60, minus 37 is also 23. And then TU is 12 plus 11, which is also 23, which is good because it's equilateral. We wanted them all to be the same. So the keys here are reading the problem, identifying what type of triangle it is, identifying which side should be equal based on the type of triangle and based on the statements like this one, and then just being careful with your algebra. So what I would like you to do now is try number 6, 9, and 10, and then pause the video obviously and then come back and check your answers. Alright, so here is our answer for 6 because it was equilateral. And then 9 and 10 are here. So we have two isosceles triangles, and these are the keys where they're telling you which two to set equal, and then once you set them equal, you are just plugging it in for the rest. So if you did make any mistakes on any of these pages, see if you can find and figure out and understand your mistakes, and if not, just email me, let me know which ones you need help with. I'm happy to help. And then the official homework is going to be the next 2 pages. I think I'll circle some that you can skip just to save you at least some time. So if you want to skip, you know what, I'll circle the ones that you definitely have to do, and then the others, if you want to do them, you can as well, depending on how much time we have left in class, because that I'm not quite sure. Definitely do 9. 9 is a good one. When it comes to 10, you're going to do 10 or 11. So you pick. I don't care which one you pick, but just do 10 or 11. I know those take a little while, so don't go crazy. And then here, let's do, yeah, definitely do 13, 14. And then if you don't do 12 or 15, that's okay, because we did a lot of extra examples during class today. All right, so if you have any questions or anything, please let me know, and please be sure to upload your work on all of these pages. Okay, so everything from page, where did we start? Oh, we started on page 1. So page 1, 2, 3, 4, 5, 6. You should have 6 attachments. Unless you put everything in one PDF, which is fine also. All right, have a good day.